All right, so let's say we've got this region, x, y is all the order pairs such that y is greater than 4 times absolute value of x, and then we pick this point 1, 3 and ask, is that a boundary point, an interior point, or neither one? So picture-wise, kind of what's going on is we have this region R, and if I were to graph that absolute value, it would look a V shape, and that would consist of all the stuff inside of here. So I'm just going to label that. Okay. Now we have this point 1, 3, and we don't know right off the top of our heads whether this is in the region, out of the region, or right on the edge. But it's easily to tell that it's not in R, okay, because it doesn't satisfy that inequality, right? Because if we tried that, we would have 3 is greater than the 4 times the absolute value of 1, which is really false, right? Because 3 is certainly not greater than 4. So it either has to be right here on the edge or it has to be out here somewhere. It's one of those two. Now, let's assume that it's right on the edge. So that is actually step 1. Okay? Assume P is a boundary point. Now, if P is a boundary point, what does that mean? Okay? That means that if you were to draw a circle around that P where it's centered there, okay, you would have to have part of the circle inside and part of the circle outside. So there has to be at least one spot that falls inside of the region and at least one spot that falls outside of the region for that to be a boundary point. And it doesn't matter how big this circle is. Now, the radius of this circle is what we're going to call epsilon. Now, that is the circle centered at 1, 3. And let's just call this B for ball. The ball centered at 1, 3. So let's make note that the equation of that circle then is x minus 1 squared plus y minus 3 squared, okay, has to be less than epsilon, because that's the equation of a circle, right? Okay. The next point to make, okay, is that the point 1, 3 is not inside R, okay, but 1, 3 is inside of that ball. Okay, so there's one point that's outside of the region. Okay? So if we can find one point inside of R that's in that ball, okay, then we know it's a boundary point. If there is none, then it's not. Okay, so we're going to pick some other point here, and we're going to say, hey, what does it take for that point, and I'm just going to call it xy, to be in both the region and the boundary point, okay, and the circle around the boundary point. Okay, so let's see what happens. Okay, so that's kind of our next step in this little journey. Okay, let's suppose for a second that that point xy is in the region and that point is also inside of that circle. So that tells me two things then. Okay? That first off, that x minus 1 plus y 1 squared plus y minus 3 squared is less than epsilon, okay, because that is in that ball. And it also tells me that y is greater than 4 times the absolute value of x. So I know those two things for sure if that point does lie inside of the ball and inside of the region. Now, using those two absolute values, because right now I'm just trying to explore what will it take for that to happen. Okay. Now, given that epsilon is really, really, really tiny, okay, and x is positive in this case because it's close to 1, right? So since it's really tiny and it's positive, we can assume that the absolute value is just x, okay? So what we're going to look at then is just y is greater than 4x. But that's because I know the x coordinate is really close to 1, okay, which is a positive number. Okay, so x coordinate really close to this 1, right, because that's at 1 and the y coordinate here is at 3. Now, with that equation in mind, okay, then 1/4 y has to be greater than x. If we know that's true, then 1 minus 1/4 y has to be less than 1 minus x. We're taking a bigger number, subtracting it from 1, so it's got to be smaller. Now, the reason for doing this is I'm going to try to do stuff with this other equation up here, and that has x minus 1s and y minus 3s. Now, I could have subtracted 3 from both sides and had a y minus 3 to make a substitution, but this was just as easy, okay? Now, the other thing to consider then is that if we were to square both sides of this, our inequality would still be good. Because if you take a small number and square it, it's certainly going to be smaller than the bigger number, right? Now, note right here that this part is also equal to x minus 1 squared, because when you square a number, it's positive, right? So, one of these is negative, one of these is positive. They're just opposite signs, right? But when you square them, it's all okay. So what I'm going to do is then make a substitution into this other inequality. If I can get this stuff to go away. Okay. Now that other inequality, we had y minus 3 squared plus x minus 1 squared less than, I'm squaring both sides here, epsilon squared. So y minus 3 squared plus 1 minus 1/4 squared, still less than epsilon squared. I took something smaller and substituted that in for the x minus 1 squared. So I'm still making it smaller, so I know it's still less than that epsilon squared stuff. And that should be a y minus 1/4. I don't know where that. All right. 1 minus 1/4 y. I'm not writing things very well here. 1 minus 1/4 y. Copy all that down right before I make a mistake. All right. Now we could go ahead and if we were to graph this, I mean, it's just a quadratic, right? Now what you'll see in the book, they factored out a 1/16. Okay, so that would be 4 minus y squared less than epsilon squared. And then they rewrote stuff, and I don't think that that's particularly pertinent, but they did. Okay. Mostly, I think to look at try to compare inequalities. But I think the easiest thing to see right now is this is a quadratic, right? And if you look at the vertex, okay, the minimum value for this, okay, is 1/17. Okay, that's where it hits the minimum. So that side of the inequality is 1/17 or bigger. Okay. All right. Now, what does that kind of mean as far as all of this stuff is concerned? Okay. Well, if that is 1/17 or bigger, okay, then that means for these inequalities to be true, okay, that the epsilon, okay, um, would need, to be bigger than that, right? So that seems to be a limit on things, okay? Because if epsilon squared has to be bigger than 1/17, then if you pick something smaller, then that point xy is not going to be in both the circle and the region because this inequality would fail. Okay? Now, one way to look at this at this point, let's see, 1 divided by square root of 7. Quit. Hold on, I'm talking to my calculator. So epsilon, okay, would have to be bigger than like the 0.24. Okay. So what we're saying here, now it goes on to say choose epsilon to equal 0.01. Okay, then epsilon squared would be 0.0001. Well, that is certainly not greater than the 0.24. Okay. If I pick something small enough, okay, that inequality fails. Okay. I could pick anything I want for epsilon. Okay. So, and if I, because it's supposed to work for every single one, right? That's what it means to be inside of this. And I should have wrote, this is for every epsilon. Okay. If it's going to be in both of them, it has to be work for any radius. Okay. So yeah, in the textbook where it chooses epsilon to be 0.01, look, that's just a convenient number to pick. It's or it's less than, I don't, epsilon squared. I should have put 1/17 there. Okay, you could pick 0.001. Okay, and in fact, 0.1 would work. Okay, it is kind of an arbitrary choice in the sense that there are multiple choices you could make. Okay, the non-arbitrary part of that is that you want to make sure that you pick one where it falls apart. Okay, one where it's less than, because if I chose epsilon to be the 0.01, okay, then this part right here is impossible. Okay. The point would not be in both the region R and inside of that ball, because it's too small. So what that means, as far as our little picture is concerned, is that if I made my circle small enough, there would be no point inside of the region. That means the 0.13 has to be out here somewhere where I can draw a circle completely around it and it not overlap that region R. So yeah, the choice for epsilon is kind of arbitrary, but there's a lot of different ones that would potentially work. Okay, if that makes any sense. But in a nutshell, one of the things that you need to think about, just as a kind of a definitions, is this boundary point, interior point, neither one. An interior point, you could draw the little circle and it stays completely inside of that region. Okay. A boundary point, so this one would be interior. Okay. A boundary point, okay, which is like right on the edge, if you draw any circle, no matter how small, around it, then it's going to have some of it inside and some outside. And then if it's neither, then you can draw a circle around it, no matter how small. You just can find one that circle does not overlap the region. Right? All right, I hope this helps a little bit. And if you need me to expand on anything or go into more detail, please let me know.